PHP is not asynchronous, and this is a problem for many tasks that require a long time. For example, let's look at IO bound tasks. So these are tasks which require communication between different services. And so many examples of this would include API fetch calls or database queries, right? And within many real world applications, you need to implement some sort of IO bound task. And what these do is they will be blocking the execution of a script. They take a long time because communication between different services, it requires a lot of operational overhead, a lot of um, time, right, to execute and to process. And so within PHP natively, what would happen is um, well, these fetches and these database queries, they would execute, and during their execution nothing else can run. All right, so even if you had some sort of unrelated code to that API execution, is not dependent on that API or that database query, well, those codes cannot run until your API finishes execution. So this leads to a poor user experience because there's longer wait times for the execution of that whole code script. And again, because of that, you lead to a lower efficiency within your software systems. Now, other programs, they do not have this type of design. In fact, within JavaScript, for example, you have something called the event loop, which handles tasks which are known to take longer execution times, specifically IO bound tasks or API tasks, essentially. And so the event loop, what it would do is this. So there's actually a diagram I wanted to show you. And this is it. A shout out to the person who made this color code. Now, within this event loop, as you can see, you have your JavaScript code. And as soon as you run something, let's say this console.log, it gets added to this call stack, which is basically like a collection of the different tasks that need to be completed. And so as you can see, it's added as soon as JavaScript sees it. That call stack is added, and then it executes right into the console or into the user interface, whatever. But now, if you have some sort of task that will block the execution of the code script because it takes super long, such as this timeout function, pretend it's like 100, right? Even if it's zero, it actually is going to have a different behavior, but we're not going to get into that because it will confuse you. Let's just say it's 100, right? So 100 milliseconds. So that will block the execution of everything else for 100 milliseconds if you do not have this event loop. But thankfully, we have this event loop, which what it will do is it will actually take this into the call stack. But since we know this is going to take super long time, it will actually be delegated to a web API. Okay, the web API within Node.js, which is where you would run JavaScript server side. It would use the libuv program. Now, once you add it specifically into the timer box, because this is a timer, well, then the call stack will just pop that function out into the executor or into the interface for the user automatically. So then, since the call stack is free, you can move on to the next code execution automatically. So even though this timeout is not completed, the execution is not completed, you can move on to the next task because this execution is now delegated to an external service, in this case the web APIs, to be handled. And so then let's look at what happens within the timer then. So let's say the timer it finishes its execution. So then the callback function within it, which is this code over here, the console.log timeout, it would be added to a queue, in this case, the task queue. And so then the event loop, which is this a program which just keeps running simultaneously, it will wait until the call stack is finished, and then it will look into the task queue and see if there is any sort of callback function from um, a resolved function within the web APIs. And if there is, in this case, let's say this console.log, well then it will add it to the call stack and then it will be executed. So then what this does is it basically frees up room for other tasks to run, whilst these heavy tasks, these tasks that take super long, they can run in the background. In this case, through the help of the web APIs. All right. So let's go through this execution manually. So what would happen is, in this case, this console.log function would happen automatically. All right. So you'd get that in the console, the script start. But then the set timeout, we put it as 100 in this case for our intents and purposes. What would happen is, we know this would block the execution of everything else if we did not have this event loop. But thankfully, we have a mechanism in place to deal with this type of function, which we know is going to take some time. So again, what would happen is it would go into the call stack, right? But then, the event loop is smart and it knows that this is going to take some time. So it will automatically push it into the web API, specifically in the timer, and so then the call stack will pop out that function, and then that's done. All right. So then it frees up room for the next task. Again, this task, same thing. It would go into the call stack, but it's going to take some time because it's an IO bound task. So it's going to be sent into the fetch API within the web API to be resolved, and then the function within the call stack would be popped. All right. Then this console.log would be ran within the console. All right. So by now you would have the script start and the script end automatically done. So they're already there. All right. This way, basically, we're not blocking this console.log from executing because of these two heavy tasks. So this can continue to execute even though these tasks are not fully finished being resolved, because we delegated them to an external service. And so when they finish, they would go into the task queue. The callback would go into the task queue. In this case, this log function, and then either one of these, both of these log functions actually, they would go into the task queue to be basically put into the call stack and then put into the console.log. So essentially, what would happen is you'd have the script start, right? Then you had the script end console. So those two would happen simultaneously. Like they would execute like that in that order. And then after that, depending on which one finishes first, you would get timeout, promise one, and promise two. So this is basically how the event loop architecture works. It essentially delegates things into an external service if you know it's going to block the code execution. And a similar architecture exists within React PHP. So, anyways, back to React PHP. That was just sort of a conceptual, high level idea of what's going on here. Again, that's in JavaScript, but the underlying architecture or the underlying idea, I guess, within event loops remains the same in this React PHP code that I built. And so this happens automatically. Within JavaScript, this happens out of the box as soon as you start using the language. But within PHP, we have to actually implement that ourselves, and we do that through the React PHP module. Now, this event loop is going to build something similar to this, and so that's what we're doing here, right? And so then within our code, in this case, within a server that I built, an HTTP server, we're basically just passing in that loop variable within here, so we can use it in this scope, within the scope of this object, because the HTTP server is an object. Well, it's a class, but then we're building into an object by calling the new. So the server variable is actually the object. Anyways, the point being that this global keyword and then calling this variable is just allowing us to use this variable in the scope. And so essentially over here, what we're doing is we created a timer function. So again, it's similar to this. This timer is going to take some time, and so it's going to block the execution. If we didn't have this event loop to handle it, it would block the execution of this PHP script. But thankfully, we call this loop, and then we use its timer function. This loop has its own method. Remember, the loop is a object. It has this add timer function. So we call that, and this will be dealt with within the event loop that is built within React PHP. And so same thing would happen. It would basically go into a call stack or a data struct a data structure similar to the call stack, and then it would automatically pop out once that task is delegated to an external service or an external executor. And then because the call stack is now free, we can move on to um, the next code. In this case, it's this code, and we can run these. And then once it's completed, the timer is completed, we can take the callback function, which is this, and we can execute that. So in this case, what would happen is this would execute first, this would execute, and then this will execute after. And this is exactly how we want it to behave, because this is going to take some time. It's going to take 1.5 seconds. So we don't want unrelated code that's not dependent on this timer, to be hung up until that timer is done executing. Any sort of code that is dependent on this timer, in this case, these two lines, they're added to the callback function. And this is true within JavaScript, Python, and other programming languages that use asynchronous paradigms as well. So here's how it would work. I'm going to say php index.php, and then I'm just going to request. So as you can see, it runs the echo first, even though this echo function or this echo execution is happening after the timer. It runs first thanks to the event loop that we built, and thanks to a similar execution as I showed you before, with delegating this timer task to another executor, and then that runs in the background whilst the rest of the PHP script runs. And so this way, the user gets something, or the user can continue working with the program, even though there are other tasks which take some longer time. It doesn't get stuck on those tasks, and that just runs in the background whilst these other codes can continue to execute and continue to fill the user with some user experience. And so that's what's happening here. So in this case, just for educational purposes, I added an echo statement, but I could add other functions as well, right? Functions that won't take that long of a time to complete. So this is how we would add asynchronous programming. Essentially, asynchronous means breaking the traditional flow of a system where you're executing everything line by line. Because in this case, I executed this first, completed this first, and then these two lines got executed. But in reality, this did go line by line. But in this case, it just delegated this task to another service or another executor to be resolved on its own, and then that cleared up the call stack or the compiler to execute other codes which are underneath it, which in this case are these two. And so that's exactly what happened here. Now, to show you a contrasting example, something different, I created this index2.php file. In this case, I'm not using a HTTP server because I'm not using ReactPHP at all. The ReactPHP is what provided me with the framework to build that HTTP server. But in this case, I'm just hosting it on XAMPP, right? I'm hosting it on XAMPP. And so that's sort of what's happening there, all right? So here it is, right? And so when you run this, right, as you can see, in this case, I had to build the timer out myself as well, the timer function. And that's simply because in this case, the React PHP provided me with a function for timer. But in this case, since I'm just writing native PHP code, no extensions, no modules, anything of that sort, I had to build it myself. But both functionalities work the same. In this case, I have that timer, right? Again, I have a callback function here, right? Um, where I'm basically, calling these two echo statements similar to what I have here. But this does not have asynchronous programming because it uses the native behavior of PHP, which again is synchronous and therefore blocking, right? It blocks code execution. So essentially what happened here, as you can see, the timer ran, right? And then this code, which happens underneath it and is completely not dependent on the timer at all, it ran after this whole thing got executed, right? And so this meant that the whole program was basically hung up for 1.5 seconds. This is 1.5 seconds. It was hung up for 1.5 seconds until this function completed its execution. And so that leads to a poorer user experience because now you have to wait more and you can't interact with other parts of the application whilst these intensive um, operations are occurring.